so this lesson we're just looking at the idea of finite difference and trying to use that to help find equations of a specific sequence. Like here, we're looking at this sequence of numbers, and we want to try to find out what polynomial would give us those numbers. So the first thing that we're going to do is just list the term values that we have. So we have 10, we have 11, 15, 24, 40, and 65. Now, what I know about each of these numbers so far is that this is going to be, this is going to be term number 0. This is going to be term number 1, term number 2, term number 3, term number 4, and term number 5. So the first thing we want to do is try to determine what type of polynomial could this be. So we're finding the difference between these consecutive numbers, and we're trying to see if they are the same difference. So like here, we're always doing future minus past. So this one is a 1. This difference is a 4. This difference is this difference is going to be a 9. And we got this difference to be 16, and then this difference to be 25. So if this first difference was the same, that would make it into a linear. Well, because that first difference is not the same, it will not be a linear function. So now let's look at that second difference. Well, the second difference is 3. That difference is a 3. That's a 5. Okay. And then the difference between this one is a 7. And then this difference is a 9. Still, when I look at those numbers, that difference is not the same. If the difference was the same, it would make it into a quadratic. But because the second difference is not the same, it is not a quadratic. So let's look at that third difference. So when I look at that third difference, I got a difference of 2. I got a difference of 2. I got a difference of 2. So because of this, because that third difference, this was the first, this is the second, that's the third, this makes it into a cubic pattern. And I know that a cubic has the form of t sub n equals a times n cubed plus b times n squared plus cn plus d. So what we're going to do is we're going to be using like these term value, the term number and its value to try to figure out what the polynomial will be. So like if I look at this, I'm going to be looking at 0. If I put 0 into this equation, so I'm going to do a times 0 cubed plus b times 0 squared plus c times 0 plus d. If I find out what those are, I know that the 0 term's value is 10. Okay? Alright, so what I'm going to do now is I'm going to do the same thing with 1. So I'm going to put 1 into this equation. The goal is for me to find out what a, b, c, and d are. So I got b times 1 squared plus c times 1 plus d. That is going to equal 11. And then I'm going to keep doing it. So I'm going to plug 2 in. So I have 2 cubed plus b times 2 squared plus c times 2 plus d equals 15. Now because there's 4 variables, a, b, c, d, in this case, I'm going to do it one more time so that I can have 4 different equations. So I'm going to use 24, and then I have a times 3 cubed plus b times 3 squared plus c times 3 plus d. Okay? So I have these equations. What I'm going to do is just try to simplify them. So I know that my first equation is going to be 0a, 0 cubed times a, plus 0b, 0 squared times b, plus 0c plus d is going to equal the term number of 10. Well, if I do 1 cubed, that's 1a plus 1b plus 1c plus 1d equals 11. That's how I got this equation. Here I have 2 cubed, so it's going to be 8a plus 4b, 4 squared, plus 2c plus 1d equals 24. And then we're going to do this last equation. So what I'm going to do is I have 27a plus 3 squared is 9b plus 3c plus 1d is going to equal to 24. So what did I do? I made a mistake here. That should be 11. And then this should have been 15. Some of you guys were probably noticing that. I got 11 right there for 1. And then 15 for when n is 2. So what I can do based off this is I have a system of equations. Now I can create this into a matrix-based system. So I have 0, 0, 0, 1, 1, 1, 1, 1, 8, 4, 2, 1, 27, 9, 3, and 1. And this matrix is going to be multiplied by A, B, C, D. So if I multiply this row by this column, I get this matrix, and it's going to equal what these answers are. So we got 10, we have 11, we have 15, and we have 24. What we're going to do is we're going to take this matrix, or this equation, and try to use this in our calculator to find the solution. So what we're going to do is we're going to put this matrix in our calculator, and also this one. So maybe I highlight those for you. So you guys got. So we're going to highlight this matrix, and we're going to highlight this one. These are the two matrices that we're going to put in our calculator. So what we're going to do is I kind of started this already. So if you guys go into second x negative 1, I'm going to put in the coefficient matrix in my calculator. So it's a 4x4 matrix, okay? And then I'm going to put all of those coefficients in one matrix. And then the next one I'm going to do is I'm going to put all the solution, sorry, I chose the same one again. So I am going to look at the second matrix being all of my answers. Okay? So I have those in. Now what we're going to do is we're going to take the inverse of this one and multiply it by both sides. So what I'm doing is I'm getting A, B, C, D by itself, and I'm taking the inverse of matrix A and multiplying it by my answers. So the way we're going to do that is I'm going to press second quit to get out of this window. So I'm going to press second x negative 1, and because I'm trying to find the inverse of A, I'm going to press A, and then I'm going to press x to the negative 1 on my calculator, and I am going to multiply it by matrix B, which is matrix number 2. And I'm going to get these values. So I have these coefficients, and what I'm going to do is, because decimals are, I don't necessarily like decimals, what I'm going to do is I'm going to press math, enter, enter, and it's going to turn this matrix into, it's going to give me the coefficients for my matrix. Okay? So I am going to end up with A, B, C, D. I have 1/3 I have 1/2, 1/6, 1/2, 1/6, and 10. So that's going to create a final equation of t sub n. And remember, now we're just plugging a, b, c, and d into that equation. So I have 1/3 n cubed plus 1/2 n squared plus 1/6 n plus 10. And that's going to be your polynomial for this situation. Hopefully this is helpful, and we can talk more about it if you guys have more questions.